Hello. We are live. Oops. Cool. So here's the plan for today. Hey Pepe, welcome. Get my chat box. Yes, can hear. Okay. We're gonna continue on kernel benchmarking today. The goal is to get. We can profile kernels. Yeah, the goal for today is to get correct kernel benchmarks for just about everything, and to hopefully start using those to really understand exactly where we are leaking perf for everything. That is the goal. And we wrote this one yesterday. In fact, I'm gonna get one additional window open for this, I think. Puffer LLM when? No puffer LLM. If I solve RL and LLMs are still done by then maybe we'd do some things. But honestly, most of that stuff is just hardware bound as far as I can tell. Let's actually, we'll take this, we'll put this here, we'll put this here. Okay, so we have our kernels. We also have let me go grab one other thing as well. So first thing is going to be to check mismatches here. We have 2.29 bill. This actually matches pretty much exactly here. So that's nice. And then we have log coefficient values. This gives us 1 bill. So, okay, right here already, right? This one is at 1.8 bill for forwards. And then way faster also backwards. So one of these timings is messed up. Yep, one of these timings is definitely messed up. Let's go check. It's not the torch wrapper, because the torch wrapper is very closely matching. We can go check the shapes real quick on this. What's wrong with Super Maven? Where's my Super Maven binary? Thank you. Alright, very nice. Okay, so in log coefficient values here. Oh, you know what? This one gets benchmarked. This gets benchmarked under no grad, right? Requires grad. Let's go check on that if we're doing it correctly. Interesting. Yeah, so I actually have the whole timing set up quite different here, don't I? Yeah, I have it set up for forward backward. Okay. Why is backwards C++? So these are poorly named right now, but that is my custom kernel versus it's not C++ versus Torch. It's the C++ Torch API without a custom kernel. So all this is essentially saying is that my kernels are actually good and make a huge difference. I need to rename a bunch of stuff, but I also have to fix all of our tests. Okay, so this is hey Jess, we're finishing the kernel benchmarking. It's actually kind of funny. It looks to me like our benchmarks in Torch are not amazing. Like these can be better. Okay, backward. Warm up the backward pass. Updated opinions on Opus and Claude Code. Where's the tweet. I need to write a full article. TLDR though, it's League of Legends. Opus is just League of Legends. It's a great game. Community shares the same 2 brain cells. It's funny. Okay, so is this what Carpathy saw? No, man. I don't know what the hell he's on. That tweet was like, that tweet was some drugs. I hate to tell you, man, I've never played the original StarCraft. Actually, I've never played StarCraft 2 either. I was not an RTS guy. Um, the thing is, none of the models have good users. It's like, there's yet to be a good interface around language models that doesn't, like, you need an interface that encourages you to think and not to be intellectually lazy. Other options? I don't, this is the thing that, like, okay, this is the key thing that, like, surprises people. I actually don't think that it's going to matter, this model versus the other model. The thing that matters here is the context and the looping, and yeah, basically the context and the looping. As well as the token speed for a model this size. Article's coming out when I get around to writing it. Simple as that. The way that I do work, I have like the top 3 to 5 things in my head that I know I need to get done, and I just work on whichever one I feel like working on any given day. I'm gonna try and make an interface. The thing is, like, you basically, I think you'd have to rewrite Claude code essentially. Um, so there's a chunk of what is in here that is usage of the model that you would need to duplicate exactly, and then there's a big chunk of like how it's integrated. I definitely like to see versions of this that are directly in your terminal editor, because first of all, this thing eating up half my screen is kind of sucky. So I definitely like to see a version of this just lives natively in Vim or whatever. You definitely don't need a fancy IDE for this, by the way. It can totally just live in Vim or in whatever text editor you have. Um, it's possible that it might want to have a sidebar, or it might want to like just be able to like have ghost comments or something. There are a few things I could see with it. In my mind, though, like this is not the most important problem in the world, right? Like I'm not going to stop doing RL to work on chat interfaces. And the reason for that is I think a vast majority of the users just want to be lazy, right? They just want to be lazy and stupid. So I don't think it's like if you just made the better interface, suddenly you'd have everybody using it. I think you'd get a pretty small minority of users who say, oh yeah, this is actually way better. Wait, Sella, since when has Carpathy had an LLM company? I think this is fine. Though actually, we don't care about this too much. So we can be a little lazy with this because we're gonna end up throwing this file is gonna get thrown away. Yeah, this file is actually just getting thrown away once we have our full test done. Like we don't need the Python version. It'll just live in C++. End goal for the week. Week is a long time, my guy. I don't know what the goal is for the week. For the day, though, is to have kernels correctly profiled, benchmarked, and start to get some insight over where our time is being wasted. Yeah, I don't think Carpathy is selling anything. I don't think I would. Carpathy is the last guy I would. Like the guy's completely genuine. I don't think there's any deceit like around that dude. And I'd be very careful with who you throw those accusations at, actually, as well, because like you definitely there are a few people that spend their whole lives like explicitly not doing that and losing a lot of money for their honesty, and he's one of them. Nvidia. So I saw something vaguely. Nothing looked super cool there yet though. I don't know. Puffer contracts are open from Nvidia. PufferLib is opposed to any other problem. This is an area of AI that I can make 10,000x better in roughly 3 years without needing a ton of resources or GPUs. That is going to be like widely applicable to a ton of areas of industry and core science research, and also will just be awesome and be the easiest and coolest way for hobbyists to get into the field as well. There's just this thing just does everything. Like there's nothing remotely close to RL for this. 7, 8. Okay, look, now we match, right? Backward SPS doesn't match at all, but let's check. Okay, this matches perfectly. Backward's actually pretty close. 541. Why is FuseScan is way faster here? Maybe this is different numels. Fuse PPO law is also screwy. Interesting. Let's go check the numbers. Oh, geez. Just in case the SSH connection drops, I'm making a quick commit. He's rich from his OpenAI shares. Well, that should mean that he doesn't need more money and can just go work on whatever he wants, right? So I'd imagine he's building Eureka because he thinks it's actually genuinely good. Do you care about money? Yeah. It's not the only thing I care about, though. Like, I'd rather have a bunch of awesome labs than a yacht, but and have a nice house and stuff, obviously. Scan b t plus 1 and h. Right? B t plus 1, 512. I do this on everything, don't I? Here's our so the very first one that doesn't match is log coefficient values, right? Let's see if we can look at that first. Opus cannot do fireballs, sadly. Okay, so this is kind of awkward. No, see, it's 679, 14. Okay, so let's uncomment this. We'll just do Does this have TF whatchamacall support? That's only for matrices, that shouldn't matter. How much did your GPU setup cost? Somewhere around 100,000, I don't know. I didn't buy it all at once though. It's kind of crazy though, because even though I'm not like consistently running the cards, I'm really only like running a ton of experiments when I'm doing like that type of work, so certain blocks out of the year. It still pays for itself because the rental cards are just so ludicrously overpriced. Then he's doing it wrong. Well, actually, the one exception I could see is if you're just like doing a project with, well, but then it wouldn't be more productive. Like, I don't see how you get those two simultaneously. Wait, 4? Yeah. I was actually, does Ford match everything? It doesn't match everything, right? Log cum sum exp. Scan. Scan. Look, the peer pressure should not be to not think. It's not like people are getting better at their jobs. Like, the people who are being lazy and not thinking are just as worthless as they were before. It's very simple. Do you want to apply effort and think and learn things, or do you not? That's the only decision you have to make. Like, you should see the difference between what I'm doing now and what I was doing the first stream. Like, I picked an application where these things would be very effective. I'm using it in a way that where I retain full and complete control over every possible level of it, right? And I'm mostly using it to cut out the bullshit time of my job that's spent fighting like undocumented torch stuff and like conflicts between the C++ version and the Python version, or between that and CUDA integration. Like, just like retain control, learn, think. Don't listen to the idiots on socials. That easy. They weren't doing anything anyways, Anish. Like, most of the FANG employees are not doing real work. The problem is when you hear that like actually talented devs get laid off, is that their managers can't actually tell which ones are doing work and which ones aren't. Like, look, the truth of it is, it's never been easier to learn CS than now. Um, you've never had the same number of people as now openly admitting that they're essentially stupid and worthless in the field. So, like, there's a lot of competition, but most of it is incredibly low quality. So, if this is somehow still an excuse to not bother trying, then you weren't going to try anyways. It's very simple. Like, learning programming is hard. Making things simple is hard. Well, this needs retained graph. This does have retained graph. But what is the mutable grad thing? See, I don't understand. What is torch mutable grad? Is this even documented? I've never seen this before. They're not vanishing inish. That's the thing. They're not. Like, no more than on normal economic cycles. Okay, so this is supposed to be the same thing. Apparently. Okay, so what else could this be? It could be the warm-up times. It could definitely be the warm-up times. Oh, yeah, this is... Okay, there's a different thing. I forgot we had the loss function. Does this run, though? I think it should. Oh, 1.38 bill? Yeah, this is way closer, right? Okay, so 2.29, 1.78, 1.38. Good. 479, 122. 179, 120. This good. This view scan off. I think this one still mismatches. Yeah, this one still mismatches. Cool. So these first three are correct now. And consistent. Man, it's really obnoxious how, like, it's so easy to mess up profiling with Torch. It's so easy to mess it up. My bad. Let's get... Steve, that's just economic cycles, though. Like, anytime there's a new super valuable tech, right, that has any sort of learning curve, even if it's a very light one, people get super overpaid for a while on it. Like, whatever. Like, the approach is the same regardless. It's just, like, learn stuff, build something worth a damn. Simple. Beginner tips for profiling with Torch. Oh man, it's like there are so many things. So the Torch profiler has a ton of overhead and lies to a lot. It doesn't give you a sufficient breakdown. NSYS is good. You want to cut out Python overhead as much as possible. CUDA graphs are nice if you can do that to cut out overhead so you can actually see kernel times. If you want standalone kernel times, NSYS will give them to you. Oh, man, there's not even like a 3 tips thing. It's just there's so many sources of overhead and so many things in between you and figuring out what the hell's actually taking up time. Like I've been essentially doing this on Puffer for a month. What kind of kernels are you benchmarking here? There are a couple gating kernels for Mingru, and then there's one fused scan operation and one fused loss. They're not big kernels. They're mostly seq level and element-wise kernels, not including matmols, that just need to be fused because our nets are small. That's just life, Steve. Some people get lucky, some people make their luck, right? And then some people work really hard and get screwed over, but there's nothing you can do about that, so not a good reason to just not bother. B, T, and H, right? And then we do fuse scan on this, log host, log vals. Oh wait, is this? I think I'm stupid here, right? Yeah, I'm gonna be... Isn't it like this? What if I do this one? Because this is supposed to be way fast, right? Test fuse scan. Slow, Celeste, and training, and inspired to start profiling and lost my evening. Yeah, but the thing is, like, Coyote, your env is just gonna be slow. Right? That's the bottleneck, guaranteed. If you stick around and you kind of look through a lot of the materials we have here, we have all sorts of stuff on building fast ends. It's really a nice way to combine some pretty chill, high performance systems dev and like low level game dev, and then also doing RL stuff. That didn't help, did it? A little bit? Fused scan. the thing with the like CS degree is like it really doesn't teach you how to be useful. It's kind of it's almost uniquely shitty in the sense that like the degree is so far removed from what is actually important for your work. Um, I don't know. There's several things that are just messed up with CS in general, like the teaching of it. But I mean, actually building stuff's pretty awesome. Okay, that's fine, but that's not gonna fix it. Actually, that could. Could it be alignment? That would be jank, right? Yeah, we're expecting it's still jank, but it could be alignment, maybe. That'd be so weird. I doubt it. Yeah, it's the old, what is it? Like, hard men make easy times. Um, what is it? Hard men make soft men make hard times, whatever the hell it is. Oh, wait, does the backward match? Does. Huh. Ooh, that's actually a good catch. I missed that. Yeah, I just totally missed that. It is overhitting the torch buttons. I just didn't see that. Let's figure out why this is. Log coefs. Uh, these empty buffers. Ooh, Nantanum. Yeah, I missed this. Let's try that again. Work on Beyond Constellation. Well, this is quite a bit of stuff, Jess. Like, kernel's got to be fast, net's got to be stable, experiment's got to work, all the end bindings got to work. We just have it like testing on breakout now. Vex got to be tested. There's a lot of crap in this. But then, yes, the idea is once we figure out the whole of the C++ backend, then mostly I get to run experiments and fix up Constellation. It's just a ton of work. I don't know what else to say. It's a lot of work. PyTorch devs to hear you out. On what? I actually can't really comment too much on the overall architecture of Torch. I haven't even gotten to that level of complaining yet, right? The only thing I can say is like the implementation of each individual thing is way, way longer than it needs to be. And they're putting too much stuff in Python native instead of putting it into the C++ with bindings. And then they're also using way too much like C++ everything. A lot of this stuff could be, I don't know. That one is more subjective. The other ones are definitely the case, though. This should be 4 checks passing. Yes, lovely. Okay, so now we got the fused loss, 732 and 1.5 bill. Opus stream went way better, Phoenix. Way better. Completely different. Okay, so this is 2 bill. Okay. Backwards pretty close. And oh, let's check the torch one. Oh, look at that. So you're dropping here quite a bit of perf. So 4 doesn't match, but this actually, the backward matches the torch one. So let's go check on this. Go check on this. The torch one doesn't match though. I think the torch one matches. BTA, BTA, BTA. Yes, good. Yeah, so now we gotta test this thing. Well, we'll double check this, and then this will be the last one, and then we'll be able to do some analysis. I'll be right back. Let me use the restroom, and what time is it? 12:47. I'll get a refill on my tea as well. 1 moment. A few minutes, really. Wow. Okay. That took a little longer than expected. I had to go fix a bug for somebody. Go fix another bug. All right. So now we have, well, we have 1500, 1500, 1500. So yeah, it's just the forward pass here is all we have left to sort out. Now this is the forward pass of our torch wrapped kernel, and this is also the forward pass of our torch wrapped kernel. So it should be right here. It just requires grad test kernel tensor of torch.tensor. Is this going to be the right D type actually? Or is it going to be like doubles or some bullshit? Okay, it's flow 32. Wait a second, these have doubles. Ooh. Well, no wonder these don't work. Now I know why this doesn't work. Testing fuse PPO loss versus this one. Good. Brain is not braining. What am I doing? Right, I was looking at the fused. How do I call this? Where's my torch function? It's here, right? And I have these as floats. I see. Interesting, right? Now you're calling fuse PPO loss. I'm calling it with floats directly. I'm confused how this even freaking works. Ha! Gotcha. That's it. Okay. Just this makes graphing. All right. Now we match. There's a little bit of overhead, but otherwise we match. Now I would like to do, there's a few things I'd like to do here. Actually, we can have Opus do this. This is brain dead work. This is not outsourcing thinking. Kernels get which ones? Min-grew gate. Referring to an LM. Yeah, this is so much nicer. Well, because like I'm literally, this is me. I'd have to go spend 10 minutes futzing with constants, right? And then I get to stop thinking about what I'm currently thinking about in order to futz with constants. And like what I'm currently thinking about is, okay, if we can get these batch sizes to match our train setting, right, then we should be able to just add up the microseconds per call. We should be able to just add up the microseconds, and that should get us close to our real timing. And if it is, we'll have a lot of confidence. Reported and blocked. No. Hmm. That's funny. Okay. I don't like this N. Great game. So like you can actually use the models to dramatically improve work output, not on everything, on certain classes of problems. Um, and you can do it in a way that where you learn the exact amount that you would learn otherwise, where you're producing pretty much the exact code that you would produce by hand, while all while being substantially more enjoyable. However, the way that everybody was suggesting that I use these models, and pretty much everything else that everybody was telling me, everything else that everybody was telling me was complete and utter bullshit. So first arg of tensor. Yep, this is exactly, see, this is the exact code I would write. Community will get worse, more worse with time. It'll get better and worse. It'll get bigger. And some people will decide that they want to use their brains, and other people will decide that they'd rather replace them with Claude. Like pretty much any reasonably smart person um, can learn a lot of the stuff I'm showing off here. There have been a few cases where I've seen like, some people that actually work very hard and they sadly just don't possess the intellectual capacity for it. But most of the time, when you have somebody who's reasonably smart, they actually and is willing to put in the effort and learn, um, they actually can get to be quite impressive. Mhm. It's actually a pretty good analogy with League because it's like the game is good, but it's also kind of designed to piss you off. So, the models are good, but they're also kind of designed to make you totally lazy. So it's like not totally your fault, even though it mostly is. It's one of those. Best paper in self-supervised RL. It isn't RL because there's no value function. You can do RL without a value function. You can actually it's very weak, but you can have RL without a value function. You cannot have RL without interaction. I don't know. This has been something that's been like fairly obvious to me for a long time, but it's one of the main things I always run into in discussions with people. Like most discussions of is RL this or is RL that is just a fundamental misunderstanding of the purpose of a definition. Like the purpose of a definition, especially when it's a taxonomy of some sort, is to draw a clear boundary around the thing that you're referring to. Therefore, you should heavily bias definitions towards being something that is like very clear to understand and has a clear boundary, right? So defining RL as learning through interaction, it is the simplest definition that captures the thing that we want. Definitions that are based on like intricate mathematical descriptions are far less helpful. They're far less easy to understand. Um, they're far easier to fudge with edge cases. So when I say that like RL is learning through interaction, no interaction is no RL, it's because this is the best definition for RL. Like this is the thing that describes RL in one line. Therefore, this should be the definition of RL. And I'm not even like doing anything revisionist either, because if you look in like Sutton and Bardo, they have this like learning through trial and error, or like learning through various forms of this, right? Deeper networks rather than shallow. I've seen some stuff on that, but then nobody ever bothers to do the flops comparison or the wall clock comparison. Designed to make money. If it didn't replace brains, what would they sell? They'd sell the exact same thing in a way that's designed to let you do more work while still thinking, rather than replacing you entirely. Like the people who are assuming that we should just hand over programming as a field or as a discipline to LLMs don't seem to realize that like programming is pretty damn well the closest thing that we have to logic itself. So when you're saying we should hand over programming, you're really saying that we should hand over thinking. And that's atrocious. It's kind of like the same way, like, oh, we should hand over art completely, as like we should hand over creativity. That's also important to humanity, right? It's not the same as saying we should hand over calculators like to the machines. It's very different. Without having any link to what the math term describes. Yeah. High school and grade 9. What min maths do I need and how do I speed up on learning it? Oh, hey, welcome. Grade 9. If you're very smart, you can do it quick. You should probably expect it to take a few years. You need to have a good first college course in linear algebra. Doesn't have to be the math department's course, to be fair. The math department's courses are quite abstract. It could be the engineering course's linear algebra. In fact, I might even recommend that. But you definitely need linear algebra. You need to have derivative calculus, multivariate derivative calculus in particular. So you need to be comfortable with what a partial derivative is. You don't need to be super happy taking them by hand all the time, though you should at least understand where all the derivative rules come from. You need to get comfortable with derivatives applied to matrices. It's a lot less scary than it looks. It's pretty much the same as your normal multivariate calc. There are a couple cases where it gets hairy, but not super common. You should know that. And let me think. I mean, you should know integral calculus. It just comes up way less often, except in a few specific classes of models. Pretty much all of AutoGrad is based on just chain rule for partial derivatives. So yeah, I'd say that. I will also tell you that while you do need some math fundamentals and they are essential, you are far, far more likely to get bottlenecked on programming competence. Like, at least for the work that I do, people screw up way more often because they are bad programmers than because they are bad at math. So, yeah, read my guides. I have a nice article on my X account. This is useful for new people. This will save you a lot of time. It will probably take you a while before you can internalize this completely. But this article is kind of all of my best advice in one place. So maybe read this every month or every couple months while you're learning. And then this is for RL specifically. And it's just on my handle here. All free content. There you go, and best of luck. We also have a ton of open source stuff in Puffer if you want to try your hand at that. Yeah, I missed the question originally, Jess. I always reply to those. Puffer your only source of income? Well, I mean, it's my company, so yeah, right? This stuff is open source, but we still do stuff professionally for companies. We do high performance custom simulations for a variety of domains. So companies can hire us to build them a sim that is spec'd for high throughput RL, and then to plug it into PufferLib and get them baselines and stuff. Okay, let's see. Let us see if this works. We build this. And grade 9 is a great time to get started. That's around when I did as well. Maybe I did grade 10. It's gotten a little easier though since then. There were way fewer resources available back then. I've pretty much been doing... I'd say I've been doing something that actually resembles programming, like real programming, since I was 14. And I've been doing something that resembles real research since I was 16. And then I've probably been doing real research since I was 18. I don't know since when I've been doing real programming. The bar for that keeps increasing. Probably around 18 as well. Yeah, probably around 18 as well, I'd say. Mamma mia. Look at this. That is a chef's kiss. So, this gate kernel gets us a few micros saved. We have massively useful. I actually don't know why the graph version is slow. We got to look at that. Let's run the, let me just compare the torch one to just be absolutely sure. Invasion for human-computer interaction. Yeah, HCI is kind of annoying because there are like a lot of really good people in that space, and then there are also a lot of really bullshitty people in that space. You know? Okay, so 960, 960, 1.78, 1.43, 1.78. Nope, this one 1.78, 1.2. Yeah, close enough. Pretty close. Log cube sum x, 479.6. That's good. There's actually quite a bit of variance here, so I wouldn't worry too much. Backwards, good. And fuse PPO losses, 1.4, 1.5. Down here, these match with a little bit of overhead. Perfect. Johnny Ive OpenAI. Did they actually do that? The problem with the labs have now gotten big, and they've hired to the point that probably they have, if I were to like pick people to have dinner with, probably some of the people I would least like to have dinner with now work at those companies, right alongside some of the people that like I'd have the most fun at dinner with. That's kind of odd. And I don't mean like people that I wouldn't enjoy having dinner with because I disagree with them but respect their views. That's fine. It's like people who I just fundamentally think are screwed up in the head and are like trying to create a shitty future. Blech. Okay. Um. Right. Now we have these matching, so we can actually concentrate on the nice new test that we have here. And we get ourselves... This test looks good to me, right? We have forward and torch. These are almost as low as a kernel launch is expected, few micros. The C++ is like several kernels, several launches worth of overhead. And then the graph version is surprisingly not that fast. That's interesting to me. That is interesting to me. Okay. And now we have log coefficient values. We have a good chunk of overhead right here to look at. Yeah, good chunk of overhead here to figure out. And the forward for this is abysmal. The graph forward being this slow is odd. Yeah, the graph forward being this slow is very odd. Eh, that's fun. That's hilarious. Oops. I'm trying to remember what I was doing. Is it 7 years ago? How long have I been working on this, man? 2017? 9 years ago. I think it's 9 years ago. Was it 2016? I think it was Willow's. What? What does that got to do with shit, man? 'Graph captures Alec and D-Alec. What? 10 kernels. Each is tiny. Oh wait, actually that's a good thing we can count. What do we do with this? I thought I had all the functions at the top of this. Oh, they're just here. Cool. That's weird, but whatever. So 1, 2. I guess is the minus a kernel? Wait, what? So wait, 1, 2, 3, 4, 5, 6, 7, 8. It's like somewhere between 8 and 15, right? The 5 microseconds. I think ours are a bit lower because I saw we have ones faster than that. So let's say 4. Yeah, the negatives do add. Okay. So 14. SD, what is the conclusion from yesterday's stream? I'm using the tool. I'm using the tools. I'm not using them in remotely the way I did from the first stream. Let me use the restroom real quick, and we will figure this out. We got it. Well, at the moment, we're trying to figure out if our profiles for coup de grace are accurate, and then we're going to do a little bit of work on like essentially breaking down the entire time that is spent in Puffer, and really understanding accurately where we're spending all our time. I'll be right back. Is it all in a single fuse kernel or separate? We have both. We have both. That's what we're actually profiling. Do I have? I don't think I do. I think I got Rocky. Using any search? No. I'm also not using, I'm not using this in remotely the way I was before. Um, it doesn't matter as much. Yeah, so we can do this. Searches. And I might add a thing later. This thing actually, I don't even know if this has done any web searches at all today, though, man. I don't think we've done any. Hang on, let me figure out what we're doing here. So I actually do like the idea of like stuff like exa. I actually really like the idea though of having having our information fed to a language model in a format that makes better sense for the language model. So I actually, in concept, I do very much like those things. Those seem cool. What's the okay? Oh, this is the wrong one, and this is the wrong one. That's totally the wrong one. Is it? Wait, 20? Yeah, this is. This needs to be. Hang on. This one, right? I definitely need to rename these so it's more obvious. Oh, I shouldn't have closed that, but whatever. Okay. I want to run the command myself. I want to see it too. Huh? Is this the wrong kernel? Yeah, I just didn't have. Reading and writing the full tensor. It's memory bandwidth. Let's get a graph profile for it. Hey, Z, welcome. I mean, we do expect to be hard memory bound. So that's cool, I guess. That's funny. That's super funny. But like, does nobody do the math on this? Because what's an H100 cost to buy? Oh, okay, so it is 2 years worth of rent. Or 2 years worth of renting it. It's way worse on the consumer chips. Like if you consider that the consumer chips are so much better for RL, you end up paying for the thing in 3 months. New way apart. The new way apart from trans. What? I have no idea what you're linking to me, my guy. Your peak with catching. Oh. .8 TBs per second. Okay, that's cached as well, okay. Cool. Launch here since there's no launch overhead to eliminate. Okay, now we do the coup de grace version. Yeah, that's X in a nutshell, man. Emergent. No idea. I really don't consume I don't really consume a ton of AI adjacent content because it's my 24/7 anyways. And I usually don't find it helpful. I find it usually more distracting than anything. Honestly, even reading new papers is distracting most of the time because most of them are wrong. Okay, we can do this one. It's only 2. We still have 4 hours of work to go. I'd say this has been good progress for the first third of the stream. I'm live about 2 hours. The thing is, you can't quickly spot BS in papers consistently. I mean, I always look at, like, do they use reasonable tasks? Do they have strong benchmarks? Are they, like, treating wall clock time as free, so they're using, like, unlimited compute for the task, like controlled variables and stuff. But the thing is, like, there are just genuinely papers where all the signs look right and they're just still complete bullshit. Like, there's no way to quantify fiddliness in the paper, right? Like, a lot of the time it's, yeah, this thing worked because they fiddled with it for 6 months, and the baselines they're using, even if they match the original ones, right, they weren't fiddled with for 6 months. And every time you want to get this thing to work on a new problem, if you want those results, you have to fiddle with it for 6 months. There's not really a good way to quantify that. There are a few authors that I know just do good work, but very, very few consistently. Eh? I think I just ran the same bloody thing, didn't I? Oh no. So we have the same time here, right? And then we just have to check the graph. I think you have to actually trace it at runtime. I'll let it try this, but I think you have to trace it at runtime. How much? Inability to replicate is a reflection of tooling. It's not that they're faking the findings most of the time. It's like there's not a quantification of fiddliness. Trying to clean up my code to be more readable. Do you prefer bigger function or multiple smaller? Jess, I tend to not split up functions that don't reuse logic very often. Like my default is I split out a function when I'm just copy pasting a big chunk of code, or I'm copy pasting a small chunk of code multiple times. The reason for that is you make the code longer, unless the argument to the function is just like one struct or something, you end up making the code longer with more functions because of the signatures. You can screw up arg order and stuff in signatures. It's really annoying. And then the big one is that you force me to scroll up you force me to scroll up to the function to see the actual implementation of that. And like I can't actually see it in the context of the rest of everything. So I think that like having a max function length in your head is very bad. I would not do that. I will sometimes break things up when it's just like there's too much to keep straight in my head, but I definitely don't approach things like as by default you need to break up. I approach things as by default don't break things up, right? Just top to bottom simplest way possible. Okay. Oops. There is also well this one I actually can't. Research was more open source and used version control. Research is not that clean, Coyote. It really isn't. Nothing more in terms of polishing. Now we've gotten some improvements, some chests. But basically, just what I need to do is I need to chill in Discord with you for a bit, for like an hour at some point, and like just go through it and see. Because I haven't been involved enough in the project, and like it's just I've been busy with this. Chess is awesome. This is going to be such a sweet environment for self play, and like it's super verifiable as well. So I just need to find some time to like go through it for a bit with you, is all. Oh, this is weird. This should not be. This shouldn't be the backward. We gotta look at this. Getting busier. Bah. Well, if you're interested, this project, there could be some professional, no promises, but this project could, like, is definitely, if it's executed well, on the level of our professional stuff, if that interests you down the line. From what I've heard from Spencer, the chess amp has been really good. Let me go make myself another cup of tea real quick, use the restroom, and then we're gonna figure out what's wrong with this kernel. And then hopefully halfway through the stream we should have everything, and then we can actually start tuning stuff. Be back. Okay. Hello, folks. Yeah. I got some soup. Which I've proven myself. Yes, of course. Honestly, I think like high perf chess is much more complex than a lot of the client ends we build, but they do have to be done fully. And it's standard. You know, first couple contracts with a little oversight is fine, but ideally it requires less oversight over time. I'm looking at these profiles while I have some soup. Yeah, that should not be launching the backward kernel, right? Why the heck is that launching the backwards kernel? Forward C++. $110 calls it backwards. That's bizarre. Forward graph. I have no idea why that's in there, actually. I have no idea why that's in there. Actually, I'll have it go look at this while I eat a little bit. Just give it this. How do I lock in? No, it's a skill. Focus and discipline is a skill. Well, the easiest thing to start with is looking at other areas of your life. How is your physical condition, right? So I am currently in the best physical shape I've ever been in. I'm not a gifted athlete at all. I just ran a sub-7 pace 5K. I've got a 4-plate deadlift, pretty decent bench. Had a major health scare a year ago with pneumonia, and I sort of built back up to that. While I've been building Puffer, I've done a couple marathons. I trained and did a 50K on a hard course. I had a few powerlifting goals. So like the outside area of my life is kind of another big sort of test of discipline, and discipline is quite transferable. So normally, I'm very happy working on my stuff for long hours for a period of a few weeks at a time before I need a break. And because I have discipline in other areas of my life, it kind of tells me that if I'm not into my work, something else is wrong. It's just not my own personal level of discipline. But you don't know that unless you actually have some other area of your life that requires it. So for me, that has been physical fitness. And in my most productive streaks, I typically have myself scheduled very nicely, you know, priority on sleep, priority on good diet, priority on getting good exercise in, and not too many other things going on in my life distracting me. That is extremely helpful. And then on work itself, I try to minimize the amount of bullshit that I have to do that just burns me out and maximize the amount of time I spend on interesting stuff that actually moves Puffer forward at a good clip. Because having to deal with a bunch of bullshit that you don't feel like making progress, that'll burn you out super quick. There are a few other sort of degenerate forms of work that'll burn you out super quick. Having tons of administrative stuff will burn you out super quick. But generally, when you're making good progress at a good clip on work you enjoy, it's easier to pull longer hours. And that's pretty much it. It's about the most comprehensive answer I can get you. I also have a lot of clarity around what I'm trying to build as well, you know? Really, the only way to guarantee you're not going to make it is to not try. Other than that, that's just like, you know, super obnoxious tech bro bullshitting. Still have the backward kernel in there. Okay. You dummy. Wrong path. Okay, there we go. Do this again. Okay, there's your forward graph. Not what we're expecting. Let me get my soup and then we'll focus on this. Still kind of hot. Here, maybe let's just do a little bit on this first, and then and I'll eat that. So, oops, hang on. All right. Yeah, these should have gotten fused, right? GPU kern sum. Yeah, that's quite odd. Oh, no, it's not. You silly. Hang on. I think it's just this, right? Node, graph. Yep. And it's not going to overwrite. Okay, let's do it again. Nice and careful. We'll follow the graph. Stats on a graph. Huh? I'm now very confused. Oh, wait, instance is 50. Perfect. So these are the warm-ups. And then we need the CUDA API sum. Wherever I had that. Perfect. And what was the one that was reporting something weird? GPU, yeah, okay, cool. Now we get it correctly. It's the wrong binary before. And we have 132 micros on the launch. And then we have these nicely compressed. Oh, I see. I explicitly turned that off. Is this better? that. And we'll have to run the other profile. Mm-hmm. $132 micros with 179 in the full forward. Let's see. GPU back pressure. Okay. Let's just try a couple more things. Node level profile. Okay. 148. This ran faster. It ran faster with NSYS on than not. Something seems odd about that to me. Let's finish this first. Oh, there's just variance. I see. Wait, no. There isn't. Yeah. Okay. PI sum. 135 micros. And then we have a similar breakdown to before. 135, okay. $25 micros is very significant at the moment. It's the same binary, it's not compilation. Okay, I don't know about that theory. I'm going to test it. That one seems sus to me. I'm gonna try this one real quick. What's this kernel doing? This is log coefficient values. It is a operation that is required during training time for the min-gru architecture that we're using as the backbone of Puffer. So it's essentially just a big fancy element-wise operation, and we are timing our kernel versus just an implementation of it in Torch. If you implement it naively in Torch, you end up with about 14 kernels. And I'm essentially looking at launch overhead, graph overhead, stuff like that. We're trying to get a very, very accurate idea of where we're spending compute and what optimizations help and what optimizations don't. How do you know what the speed of light should be on your card? It's not that fast yet, man. That's not we're bottlenecked by things that are not that. Yeah, so I did this correctly. What peak performance? What speed of light? Um, so again, we're not even yet at the point where we're optimizing the kernel. We're comparing lift of the kernel to defaults. This There's several quantities we want to estimate as a result of this, right? What's the price of an extra kernel call? What's the price of an extra element-wise op, right? What's the price if you fuse an op of just doing the computation? There are a lot of things here. These are very small kernels, so we're dealing with like pretty tight timings. Like saving a microsecond probably gives us almost 1 full percentage point of performance. Okay, 175 still. Oops. Graph. So yeah, still identical. Let's get all the kernels back. Let's see what our profile gives us now. Interesting. Interesting. Wait, 194. If I do just profile graph, maybe? Hang on. Oh no, it's worse. Yeah, it's actually worse. Yeah. So profiling code is the most important to have correct in your entire code base. If your profiling is wrong, you are screwed. This is important. We'll try this. So I'd be a little surprised if that messes anything up. We do have it in the warm-up. So actually that shouldn't be able to break anything. Interesting. It's decent. $182. $92. Very bad. Oh, we'll try this one. I'm a little bit suspicious of this. I don't know why you would need this, but like this. Like this. Four element load for each. Overlap these kernels with each other. I don't think any of them overlap, no. Just from the log and F. I don't know. I mean, we're really not at the point where I should just like start optimizing each individual kernel yet. We just really need an accurate profile because I want to be able to sum up the time of these. I want to basically profile these individually and then compare that to the time of the net and see if it sums the way that it should. This is quite a complicated thing that they're a part of. Kind of have to do both the whole profile and then piece by piece. Okay, that's not all. I'm trying to think where this could come from. You know, like where are the possible sources that this could get gotten introduced? Okay, fine. You can do this for a bit. That's fine. We'll try that one. Let me rerun that in a moment. Finish my soup first. See if this gets us into range. Okay. Now we can do the NSYS one, right? But now this is slow. Interesting. This. So 189 before. Hey user. 78. And then NSYS. Very odd. That's quite bad. Does it set some other flags? Okay, fine. It's kind of a silly thing, but maybe. So many little things that mess up your profiles. God damn it, that did it. Now it matches. Matches perfectly. Literally just some warm-up crap, but then if let's say I do all of them. Little more than fuzzy docs. They're a fair bit more powerful than that, but you don't want to use them to replace thinking for sure. Do I like this? Okay, that actually seems reasonable. We can try to redo the warm-up. Fragmented memory. That's weird. I would highly doubt that. That wouldn't make any sense to me. Oh, warm-up GPU. Forgot to move this to the top, silly. Paired head attention. 3% impact for 0 params. It's a pretty small one. That didn't help. Yeah, I'm not seeing anything that could cause this, but it's a very consistent behavior. Okay, fine. We do fresh tensors. That's a good check. Yeah, we do fresh tensors is fine. That shouldn't make a difference, but at this point I wouldn't be surprised. Nope. Same as before. Use the restroom real quick and we'll figure this out. This is bothersome. That's a 40 microsecond different profiling. There's a 40 microsecond difference. Let me take a look at this manually for a second. Hardware accelerators. Now we'll start making some stuff like. I mean, the main thing is if you know some low-level dev, there's really not that much to tell you. If you know C, CUDA's C that runs on your GPU. If you're used to profiling C, now you're profiling CUDA. If you're used to optimizing C, you're just optimizing some CUDA. There's some more stuff, but that's enough to get started. I'm trying to think of like what else. I mean, this path does go through Torch. What else could it be? The hell? Weird. Multiple streams. Forcing default stream. Was this? Okay. Oh, I see. Yeah, that's a good thing to check. That is actually a good thing to check. So what is slowing? Yeah. Yes, the forward from the graph. I mean, this is not a slow. I mean, I guess that tells us the graphing is fine. Allocator return from warm-up iterations. Would be very odd. Playing the graph has overhead from caching allocator interactions. Graph is not designed for dynamic allocation patterns. Just a single kernel. Static patterns, okay. Okay. Captured code as allocations, yeah. Hmm. It's about as good as we're gonna get. This still bothers me. Get rid of the chrono. This one. And we'll keep the overall warm up because that one did help. Yeah, this is good. Let's see if we do some math here now. Yeah, okay. To get all of our profiles. Just get all these, and then this is pretty much our maximally clean profile. Okay, this kernel sucks, but we don't actually use this one, so don't worry about that. This is the one that we care about a lot. Yeah, this one matters a lot. And this one's actually not free. 50 micros with the graphing. Okay. I like this. Let's make a quick commit. Okay. Seven million steps per second training. It is stable, it seems. Yeah. 19-second solve. Perfect. Okay, so now we want to run NSYS on this. Let's go get the old script. We had a different script that I just didn't save. Like here, we can just do like this. Then where's the graph option? right? Here we go. Runs at full speed, we'll notice. Should output stats in a moment. And we want to see the relative timings of our kernels. And we can see if they match expectations, etc., etc. It's good. Oh, there it is, it's generating. Well, this will actually, I think it just prints everything for us, so we'll get to see it. And hopefully, we finally will have enlightenment. Where are our kernel names? Oh, there was also the was it NVXT? Do I have that on? This has to be true. So this potentially does drop a little bit of perf on our profile. Do this again. Oops, could out of memory. Here we are. Yeah, so this is taking a pretty sizable bite out of perf with all these extra device synchronizations. That's why we have it under a flag. Still though, 21 second solve. And we need NVXT tags. And the cool thing is now we can actually see whether this matches the expectation. Like we're going to be able to see the tagged regions that correspond to our kernels of the code. And let me just go get a command ready for this. Nice. Oh, here it is. I don't even need the command. It's 174 microseconds. .9 ms. So this is 3 milliseconds. Cool. These timings, though, well, let me go remember. Let's go remind ourselves what the heck these are. Yeah, so this is the whole thing, right? GPU kern sum. I suppose now what we would do, right? So we'll do so we'll take CUDA graphs off. We'll take CUDA graphs to be off, right? And then we will rerun. And we'll see if we get our kernel timings way slower. You see this? Way slower. Meaning that even with our custom kernels, we still need graphs. Kind of funny that our super slow version is still sub 30-second solve for breakout. PufferLib is fast. Very fast. G.AI. It's funny. Kernel's been going. So we have very good profiles at the kernel level. We also have very good profiling of relevant tagged regions of our training code. And now we kind of just need to, between the two of those, figure out what remains for optimization, which is what I'm doing now. And I'm very happy that I have the kernel profiles as well, because the kernel profiles are way faster to run than the whole training profile too. Okay, here's the whole training profile. Left, you see, gigantic mess, right? And we can see, let's see the overhead. Okay, so this was 3 milliseconds before, and now it's 3.8. So without graphs, we lose a chunk of perf off of this. This one was 170 before, so this actually, it's twice. You lose half your speed right here. You lose half of your speed without graphs. So graphs are going to do a lot for us. And everything else is fairly small. New PB in neural MMO3. Maybe. It'd be cool. I'd say I'd take it as a bonus. This architecture is not meant to be like better. It's meant to be as good and much faster. If it happens to end up being better, that's cool. But it's a bonus. Okay, so is this actually, does these even add up to 100? So that's 0.7 seconds. Hosted device. I guess we can figure it here, because 13% is 0.7 ms. Okay, so this does not sum to the full time. We also have a bunch of CUDA launch overhead. You see this right here? Yeah, this is 2.5 seconds worth of launch overhead. Whereas up here, CUDA launch kernel, we have 0.2 seconds worth of launch overhead. So this is the major savings, is we save a little over 2 seconds worth of launch overhead on this. So now I suppose, well, the thing is these times are going to get magnified, right? Because these are the timings on, I guess if we think of them as percentage-based timings, that it should still be accurate. No, because these don't sum to 100, do they? Yeah, why don't these sum to 100? Actually, I'll let I suspect what's happening is that these don't add for some reason. I bet this could be percent time of... I actually don't even know what the hell this would be percent time of. Need some coup. You really don't need some coup to ends. Fine. Oh. They do add? Really? Interesting. How the hell does this add to... No, I'm not trusting this. I'm gonna be really stupid here, okay? Is it just a long tail? Okay, it's just a really long tail. Yeah. Uh, Actually, that's gonna only get me up to 90. So either I miss something or it's like 90. Regardless, it's not that far off. It's fine. A little bit about PufferLib. What do we have here? Ultra high performance reinforcement learning development. Currently, we are looking at a bunch of custom kernels for the next release, and we are trying to figure out where we are losing performance on everything. That is the idea at the moment. I mean, it's kind of janky to be doing it like this, because, like, well, actually, how much higher will the percentages be? If we do 0.7, let's see. 0.7 divided by... Okay, you know what? Maybe these get to be close to twice as important. So we've got... nope, not on LLMs. We do very small model RL for specific tasks. It's all open source and you can play with it at home. You can literally train agents in seconds on your laptop if you have any GPU at all, or minutes on a CPU. We've got tons of these in tons of these demos. They run in your browser. Most of these agents you can train at home very easily. A few of them you need a couple GPUs for. And it's pretty fun because you can get superhuman agents very quickly. They're useful in a number of applications. And we primarily use games in research for testing. We're currently targeting 10 million step per second training, which is, well, agents that are able to play the games at millions of times real time. play the game, drive the sim, whatever it is. Not just games. See, this is just a really flat profile. Heh, I gotta go add some credits to this. Agent is someone who only uses Python. Python only during my IT class. Well, the thing is, you can kind of just train on any of our existing environments out of the box. So you don't really build an agent. It's not like a language model thing. So you can train on any existing enms. For new environments, though, we strongly recommend C. All of our enms are written in C. It is very simple C, but it's like 100 times faster out of the box than doing the same thing in Python, the way we have our stuff set up. So we do a lot of low-level dev around here. It's pretty chill low-level dev. It's a great way to learn stuff and also do some AI. But everything is very performance critical. Things need to be fast. As we can see by the fact that I literally stream months worth of timings work to make everything faster. I will fix this in a second. Let me use the restroom real quick, and then what we'll do is I think I want to like just get some better aggregate profiles where we sum up the total amount of matmul time and like the total amount of Cutlass kernel time and stuff. Because this is not an accurate enough overview for me right now. I'll be right back. All right. Right, I need to go fill up credits. So that means that we used $100 worth of credits in, what was that, 3 streams? 2.5 streams? Cost. credits. Another. We're not going to auto reload credits. Topological research in Java, that's cool. We're definitely interested in helping various fields of research with this stuff. Our RL is very, very, very fast compared to what is out there at the moment. The current version of PufferLib can train between 2 and 5 million steps per second. I'd say reasonable, like 3 million. The next version of Puffer that I'm working on now, we are targeting 10 million. We have a stable 7 million step already. I'm trying to get 10 million before release. I think it's doable. I mean, we're going to see today, I suppose. Yeah, what we're going to want is group all the element-wise kernels up, group all the cutlass kernels up. And we should be able to make some good progress. I don't think we have that much in I don't think we have that much in Matmul. I think there's quite a bit of overhead still. Material science, how do you frame that as an interaction problem? So the dumbest way possible I can think of this, that I did check with a material scientist and he said was not completely insane, was just have all the atoms steer themselves around like little cars in order to maximize a specific property. So all the atoms just steer themselves into a configuration, and then you have you can mathematically check certain properties like thermal conductivity, etc., etc., and just like reward for maximizing that property. Stuff like that. If you can make the sim really fast and good, like close enough, this seems not completely stupid to me. There are probably way better ways you can do it, but that's like the first thing I would think of to do. Hang on 1 second, folks. I gotta go fix one bug. Be right back. Okay. I mean, we can also always do this as a post process if we have to, but ideally we don't need to. Yeah. This is not exactly how it works. Sort by CUDA grid and block. Interesting. This is stats. Base. Ooh, base name grouping. Okay. Without the template parameters. I will do like this. Kernel 2. Yeah, this is way better, but where are my names? Oh no, that's exactly what I'm getting. I'm done. I'm done. Kernel 2, but what the heck is that? Tensor op. Kernel 2. Call this tensor op. Call this gem. Base stripped this. I think maybe there's some other options. I mean, we can keep this. This is not terrible. Kernel 2 is it's a gem, right? Element-wise kernel, vectorized element-wise kernel, reduced kernel. Well, that's a heck of a query. Yeah, let's not. No, that's enough. Plot. That's enough. I'm good. That's too much. Let's do. Double check some stuff. Let's try this one real quick. Because this actually might make a difference, right? This. Okay, so we shall see with this. This is not much faster. This might just take some of our element-wise crap out, though. We shall see. I mean, at the very least, I'll know that this is not the thing that's taking up time. A huge amount of crap in element-wise. We also know, hang on, we also know that fusing kernels is massively better than graphing kernels because of the mem bandwidth in this case. So you only graph what you can't fuse. Yeah, you only graph what you can't fuse. Okay. And this we just did, no graph, cool. So, still have element-wise kernel. This concat actually, funny enough, is really slow. Reduce kernel. This is most of it. Cool. This is 3. This is 5, 35. It's like 35% of the time is just on element-wise kernels. If I graph this, I think that there's a way to do this. I think that there's a way to do this like how I want to. Watch this. If I do node level, right here, okay? So I think you still get the node level profiling, but then I think I can turn profile off is the thing with this. Oops. I can turn this to true and this to false. I think this is the move here. We don't even have to recompile. And we'll try this again. Okay, so now we are at 6 mil. So we're only taking a 1 mil SPF. We're taking a 1 mil SPS hit, presumably for nprof, injecting kernel level information despite the fact that we're graphing. But this is still way less of a hit than we take for disabling CUDA graphs. So this should give us a much more accurate profile. You want your profiling runtime, profiling speed to be as close as possible to the real run speed. And we will see from here. So this is now within like 15% of our actual speed. And we'll see if we still have a bunch of element-wise kernels or what. Or if this just crunches names, we'll see. Probably takes it quite a while though without the graphs on because it's just massive. This is a 5090. Okay, here we go. You could ignore the fact that this isn't working. There are a couple bugs in the fuse kernel. We're just doing it for profiling though. It's not that big of a difference. We just don't want like all the extra ops in there. Plug directly via. I'm using the API. Do they give you a reasonable number of tokens with the monthly plans? Okay, so this is what we want. Now we want the aggregated version. And now we have it, right? So 29% is 2.2 seconds. So this is actually very close to the full profile now. Increasingly miserly, then I just use the damn API, whatever. Okay, so with everything on, this is what we get, okay? This is some overhead. We are syncing like 9% in the fuse scan, 5%-ish in log coefs and vals, 2.2% in this min group. We've got 30% of our compute is real compute. These are map moles, and everything else is kind of bullshit. A couple of gems down here as well, I suppose. Okay. Well, it does this. I'm going to check the optimizer. I'm going to check the optimizer. Still doing manual type, yeah. I mean, I'm reading all code as well. And I'm not really having it like design shit either. What do we want to do here? So I think what we want to do, if I don't do the backward passes, what if I don't do the backward passes? Let's do this. Hey, Tim. Yeah, so this cat is heavy. We know that this one is fine. 2 D-type cats. Not element-wise, right? Ratio copy, copy. Those should show up as copies. This level of profiling that it shows here, we can easily investigate with tags. So we actually don't have to worry too much about this. This goes up to 8 mil, so this is definitely overhead. So the optimizer is definitely slow. It's this. Heh. Yeah. Instagram. No, why the hell would, like, nobody should ever install either of those ever. Why would you do that? Okay, so now we got all these freaking profiles, and we're gonna do no optim. What changes? 29, 20, 10. Does anything change substantially? Yeah, I don't know. It's freaking Twitter. Ignore this. Wait, where the heck did this compute just come out of then? 22 is 28%. What? Eh? Alright, we're gonna do it the dumbest way possible. I'm gonna take a screenshot of it. So where'd my screenshot go? Okay, no. These flat profiles are the most obnoxious things, I swear. But it's much, wait, how is this much faster? But we're seeing the same kernel timings. I'm confused. Maybe it's copy overhead? Well, okay, that does not make a major diff. Yeah, I know, I haven't updated my website in a long time. You either pretend to be doing work or you are doing real work. At the moment, I'm too busy doing real work to pretend to be doing real work. I will use that as my excuse, thank you. Found a what? Hey Nalacha, welcome. We are optimizing kernels. This is super weird to me that this is not. Is there like a gem or something that's up here? Wasn't there before? No. Okay, so that's super odd. We have the element-wise kernels in there either way. Oh, you know what? Ah, we don't have the region tags on is the problem. Okay, let's try this with the region tags. Let's try this with the region tags. I think this should be better. And actually, get rid of this no opt-in thing. We'll just do this, yeah. Puffer 5. It's pretty much, it's like curriculum learning built in at the level of a trajectory segment. It's related to Go Explore style stuff. It's planned. There's still a lot to do before we even get to think about, though, frankly. Okay. I think this is going to be proper profile. Build this. Wants to be visited 10. Hang on. Sometimes it filters in it. I don't know. Use the restroom while this runs. Real quick. I've been drinking tea all day. Yeah, the way it works is it runs for a while and then you get to see. Does not contain any GPU trace data. Oh, yeah, I think it break something. No, it's good. Fine. So this will give us, with substantial overhead, this will give us region profiles and kernel level profiles. It'll show up. Give it a second here. Oh, your message. I don't know about that. Are you typing like ridiculous keywords that YouTube's auto-filtering? Tries to filter links and it's like common spam sometimes. This thing's cool. Oh, that one? Yeah, you found the my high school website, right? Yeah. That's a fun one. And let me figure out what this is. Yeah. Maybe in a sec. Let me finish this. Okay, so these percentages are roughly the same, which is what we want. There's quite a bit of overhead, but that's expected. Now we get region timings. Oh, that? Yeah. Here. I was like 15 or 16 in this post, this picture. This is me like trying to train awful convnets in frickin' MATLAB of all things on CPU. Yeah, this is what lack of autograd will do to a guy. Yeah. Okay. Quite a bit of overhead in these, but these are still usable. I mean, it was like, it's a good resume for that age, I think. Oops. Weird. Is dead. Respect to sweeps. Put in dev channel. Let's see. Come on. Wait. Ask Joseph. Parameterize end difficulty. Scale score with difficulty. Sweep score. Just find hardest solvable difficulty. We kind of have this, Finn, with we kind of have this with our maze env. It's a little tricky because like You'd have to be pretty precise about it. Like, is the score going to be the like largest maze for which you have a 95% solve rate, or like because you're training on a bunch of different difficulties at the same time is the idea with curriculum learning. Yeah. Parameterizable difficulty is definitely useful though. It is almost 5. I got an hour and I need to make sure we make some good progress here. I want to make sure we have a good idea today, at least of the remaining bottlenecks. So half the time is spent in training. This is a straight up graph replay. %30 of our time is spent in rollout of graph. That's 80% right there. Core network optimizations are likely the biggest thing. Where the heck could 30% overhead be coming from? Do we have a hang on. Average time, nanoseconds. Ah, look at this. You see? Wait, if we group them, it's still there. Okay, cool. So the average call time, this is 3.8 microseconds. So this is pure kernel overhead. The vectorized ones are even faster. There are just a lot of them. And that is a crazy number of matmul calls as well. And they're tiny. State single var. You can try it. It might be like kind of correct. It's just a bunch of slides, I think. I might have videos still on there. It's me attempting to explain things I barely understand. I remember spending like hours just lying on the floor trying to understand backprop. It's actually like a pretty damn complicated thing if it's introduced to you without the idea of a computation graph. Like, good luck. So, massive number of tiny kernels. Oh wait, the key thing here, these are getting graphed, but they're not getting fused. That's the key thing I'm missing. 140 page. So a Walrus Tale is not a 140 page novel. That's a children's book. Do I have that novel somewhere? I don't even know if I have the text of it anywhere anymore. The hell? Come on. Yeah, 140 pages plus. Yeah, I was like, I got like, I don't know, 200 pages into writing a novel or something. Funny. Did I have? Oh yeah, I forgot about that. I think if I remember, I didn't have a perfect SAT. I lost a few points on the essay or whatever because there used to be an essay, and then they changed it so that they no longer had an essay. So because of that, I ended up with a perfect score with the new system. I forgot about that. Barely matters. Whoops. There's nothing sensitive on there anyways. It's just the Anthropic credits. No, that's just the Anthropic credits. There's nothing on here. Okay, so here's what we want to figure out right now, okay? So we have, where's the epochs on this bloody thing? 97 epochs. No, not 97 epochs. 229 epochs. Okay. So 8192. Oh, it's 64 iterations. So forward pass, it's 64 iterations. 4 layers. 229 epochs. This gives you 58,000 expected matrix multiplications. I believe it's plus. You also have 16 during training. Okay, so this is quite far off. Let's see if we can get this through Claude. Like, it's like, why does it not let me paste, man? Mandarin. I've taken that for a while. Spanish, my last name is Suarez, though I actually did have to teach myself most of it. I actually got the fluency after I got into college, because pretty much like I had zero free time until I got accepted, and then I ended up with a spare semester. So, instead of taking a break or doing something sane, I decided to study like was it I think it was 3 years worth of Spanish. There's like 3-ish years of Spanish and 2 years of Mandarin in about 3 months. So that was cool. I don't know. Languages aren't that hard to learn, they just take some work. I mean, think about it, right? Like, literally every person in that country can speak the freaking language. No, I was way better back then, man. I worked way harder when I was that age than ever afterwards. But, like, I don't know, it's harder when your work is like this. The stuff I'm doing now, it's very difficult to work a very large number of hours and be productive and also not be like, getting your mind sidetracked and working on the wrong thing. Oh, encoder. I forgot we have a few more layers. Fine. Split K. That'd be weird. Matmul related kernels. Okay. I'm trying to just get the back of the envelope here. And these kernels are freaking tiny. I mean, if I cared, I wouldn't have it on the internet, Roger. I honestly feel lazy by my own standards most of the time. Like, this is only going to be a 6-hour stream. 6 hours of programming in a day is not a huge amount. Six hours of debugging CUDA is slightly more, to be fair. Okay, so this is the number of matmuls we have in here. I didn't multiply by 7, so it should be by 7, right? Times 4 times 7, 128. Muon is also doing matmuls, yeah. It is actually. It's doing 5 per update. Oh no, it's doing a lot. Yeah, Muon should be doing a lot of matmuls. We should check that. So without Muon, Let's do like this, right? Easter eggs on the internet. Let me go double check. It redirects to my. I used to have a thing. It's not there anymore. I don't think there's much else then. Do I work for a company? Puffer is a company. Puffer is a private research lab. All the stuff you're just seeing here is free and open source, but we also build high performance RL sims for companies. We do contracted R&D. We do a few other things. Actually, let me go double check. Speaking of which, thank you for reminding me. There is a client I needed to message. Yeah, let me make sure I message this. There. Thanks for the reminder. Lucid interview? Oh, geez, that is old. That is really old. That is actually before I knew what the hell I was doing as well. They didn't really know what they were doing either, though. Okay. So, here's what we're gonna do. This is gonna be the no optim one. Optim. Yeah, we'll run this. Hopefully this tells us something. And then if if the matmals add up, then I will believe the rest of the element-wise operations. And essentially, it'll just be like, yo, you have too many bloody operations. That's literally what it is. Like, hey, I know that you tried to reduce the number of operations. You still got too many. Keep going. 8 microseconds per matmol's nuts. I don't still write for fun, sadly, Justin. I did in the past couple years. I finally started reading a bunch again. So pretty much whenever I'm working out, I also have an audiobook. I've gone through, in the last 2 years, 20... it's probably like 50 books or something. I don't know. If I'm doing like a good running training block, I go through them pretty quick. One every week at least. If I'm not doing as long of like more endurance sessions, a little slower, but still pretty good. Not vlog. I don't actually travel a lot, Anish. I traveled a lot when I was younger, to the point that I really don't enjoy traveling anymore. I'm kind of all traveled out. Like, I really don't have a huge list of places I want to go or things I want to see. I mostly just have a list of stuff I want to build. Okay, look at this. 115, 128, way closer. For 10 seconds worth of profile, this thing took 19 seconds. That's very close. 115. So this was 1.8. What? But what? Oh, what? How? How? Wait, 1.9 seconds for 200k instances, 8.4 NS each. Okay, way fewer. Okay, they take twice as long. They take twice as long. Okay, so okay, actually, let's do this. Put this in here. Oh, 600k. close init ingest. Maybe, I don't know. I don't know if there's a way to see those stats. I think we do actually have, it's just gotta be mem bandwidth per op, right? It's literally just gotta be mem bandwidth per op, just like fuse more shit. Absorb cat plus pad. Yeah. I think that's gonna be it. This cat's actually, the fact that that one op takes so much should tell us, really. It's just, it is just by 1,000 cuts. Okay. Two hidden and gate immediately gets chunked. Is chunk a kernel? Yeah. Output as well. What about the rest of us? If this all gets graphed. Output gating into scan. Could do that. Oh, maybe there is. Yeah, there should be, right? Yeah, no, we can definitely do that. Because we don't even use them after that. Yeah, we can totally do that. So this can 100% get fused. This can 100% get fused into scan Philistine. Because I do shit in I do shit in a really simple, dumb way, and it usually ends up being very effective. I don't like intricate, clever things. I like simple, fast things that work. I'm gonna let me make a couple quick commits. Before I mess something up. Do this one so it works. Okay, ready? We do this. Oops. Okay. Oh, that's nothing. Fine, that's nothing there. Cool. Not losing anything. This is giving it a little too much control for my liking. Um, that's funny. State. Next, hang on, next. axis. Yeah. Is that a good idea? No, it isn't. Getting some good use, yeah. It's a soccer player, right? Everybody I say off Suarez, oh, Luis Suarez. Oh, sorry, football player. It's a pretty straightforward modification. I'm actually fine letting it touch this. What I want to do is I want to make sure that I don't let it mess this up. Scan. Is this the way to do it? This is actually a, you know what? I'm gonna let it do it because I have a test. This is a very fiddly numerical piece of code. I do have a good test for it though. It can do the modules just fine. I don't know about the kernel. The module changes are trivial. Yeah. Okay, this we have to review very carefully. So this is going to take log values from state. These changes, this is fine. This is very simple. Okay, this gets t plus 1 steps. Passes state. This is, all this is fine. Yeah, Gino, this is, we will see. This is a very tricky kernel. It looks very simple when you look at it. I promise you, this is not simple. This kernel's actually pretty evil. Though once, if we can get this fused, I was actually thinking of doing it, like trying that with it, because this type of kernel dev is just really hard to think about. We'll see. It's like very unintuitive, the type. Well, I still don't want to give it too much control though. Okay, this is fine. Yes, this is fine. This was not a question though. This is easy. The backward function is the same thing. The only thing that's actually hard, the launch functions are also easy. The only, like, that's nothing. The only thing that I'm going to want to be very careful with is if I let it touch this kernel. That integration is not easy. Yep, so this is just recovering buffers. Grad state, these are all fine. These are all fine. Okay. Okay, there's nothing weird here so far. We might want to end up like fusing these values at some point. But I think for now it's good. Again, this is not the worry here. Okay, so we have Again, this is fine. All this is updating some signatures. There are a lot of signatures to update because you have to go through the torch binds, the torch class interface, the launch interface, and the kernel interface. That is like very obnoxious and tedious, and it's very easy to make mistakes doing it manually, but it's not difficult. Now we're at the, oh, it just went ahead and did the kernels. Cool. Not t+1, yes. Okay. This we need to spend some time on. Yeah, I need to look at this. Base, out base. Let's see, where does it say out base? Out base, okay, same thing. Plus t times h. First time step uses log with state. Twelve is 0, yes. Okay. I don't know if this works because I don't know if this is also a guard. This infinity is a guard on numerical overflows. I think it might be. Again, we have strong verification on this. Okay. Oh wait, it left this in. Okay. This did add an additional pathway. It does maintain the infinity though, so I'm more confident in this. This one's going to be a pain. Okay, so we add grad out and state. No, we change grad out just t+1 and state, okay. Out base. Sure. Okay, so this is now log value for time step. This is the input. And there's the derivative. So this is messy, but this is what I expect to be here. In the interest of time, we're going to take this and see the numeric check, because this is like directly verifiable. And we actually have 3 layers worth of checks we can apply. 2 layers of easy checks. Launch functions are trivial to update. Yeah. These are just the launch functions. Okay. I give this a 1 in 3 shot of not having broken the numerics. And then the PufferLib update is again trivial. Yeah, because this is just a fuse scan update. This is going to update the signature, and then this is going to update the call to move the cat into the path that is not fused. It should be like 3-line update or whatever. Yeah, 1, 2, 3, right? Move that into there, delete from the top. That's fine. So exactly what we expect, except I'm not super happy with the module modifications are fine, the launch modifications are fine, this is fine. The kernel we will have to see. The kernel we will have to see. I'm going to intentionally only compile the PyTorch version of the test. Also this launch. See, like there are a million places this has to be changed. This is one of the reasons why this is good right now, because like normally I would just design a thing so that you never have to change something in 10 places. There's actually no way around it with what I'm doing here. So oh, it actually did. I didn't think it was going to remember to do this. State must be positive. Yes. I didn't think it was going to remember to do microbench. That is the correct build command, sure. Probably doesn't need to run it. I could run it for it. Just burn some tokens for no reason. Oh, is it erroring? Is that the problem? No, okay. Huh? Yes, that is the correct command. Let me go do it myself, though. Thank you very much. Okay. I believe those are passing to the same talls as before. We will see when we go to do run training. Okay, I'm actually very surprised that that is stable. That's actually very, very good. That's actually pretty genuinely impressive. That kernel change is not easy. The rest of it, trivial. That kernel change, not easy. We need to re-benchmark. We definitely need to re-benchmark. So in order to do this, profile has to go to, wait, do we need profile on? We actually kind of don't. I just need the op calls. Okay, so yeah, what we can do for this, okay, what we need for this, we just need nprof. So you take a 1 mil SPS hit, a little less for profile. Oh no, look. Yeah, 1 mil SPS, because it just dropped the profiler off right there. Cool. So 1 mil SPS hit for profiling. Expect about a second's worth of overhead for that, actually. Dropping some of our graphing perf. This is also not running the fused loss, though. I need to probably do that. I am curious, though, to see how much slower this makes our fused kernel. Because presumably we're going to be able to optimize the fused kernel from here. Ideal case would be fused kernel is now a decent chunk of the perf, or of the time. Not positive it will be. Because we should have gotten about a 6% boost from that, and I don't think we did, right? We got a... hard to say. No, we didn't get 6%, though. We should have definitely gotten at least a 6% boost. And we're expecting more time in the kernel. Right? Okay, so now we need to do... Where's the command? This one. And I'm actually going to just take this command. Before I forget this command, I'm going to go put this into the sh file. Oh, element-wise kernels are down a little bit. Wait, hang on, is this? There's a ton of freaking calls. We kind of need to take the PPO loss out. Oh, here's view scan backwards. It's over 10% now. Let me go get the fuse scan backwards. What do I got? I got 10 minutes left for this, and then I gotta go to dinner. Before my family decides to report me missing or dead. Okay. Let's go grab the Puffer C++. And what are we gonna do? Fused. Let me do this. Rebuild this. Sys and dot. This is what we want. Good. Python. Yeah. Yeah, this does not execute cleanly at all. Yo, what's up with my mem usage? Why is my memory like this? What? There are no processes. Huh? I mean, it should be fine anyways, but like, what the heck? You know how you can even do that, but whatever. Okay, so it's not going to train now, obviously. But it will end up being 7.4 mil without the profiler on. So once we fix this function, we'll be happy. And then we'll go look at this kernel, and we should actually get something meaningful out of this, and then that'll be it for today. And we'll be able to do more tomorrow or whatever. Well, I have some client work to do tomorrow, but you know, you get the point. Soon. Always outputs good ground truth info. There's limited work where you can do that. Chess move gen. Okay. Last thing we need. Right here. $5.9, $4.4. Over 10% is being spent on this kernel. Cat array batch copy. I am actually, I don't know where this is now. Actually, let's I bet you this is grad clip overhead. Still way too many element-wise kernels. Reduce kernel. It's funny, I know exactly how you do this, but I don't know how to do it with Torch. %30. Everything else is much smaller. 5% on log coefficient values. Okay, this is the data that we have from today, guys. So we actually now have a pretty damn good understanding of where we can optimize. 30% is actually pretty hard to get. Like, it's just that the operations are absolutely tiny. That's the main thing. Okay. For folks who've been watching, thank you for watching the 6 hours of profiling kernels. That's literally what the stream ended up being. We will do another 6 hours of profiling and optimizing kernels soon, I'm sure. If you'd like to support my work for absolutely free, feed this puffer a star on GitHub. Star the puffer. If you want to get involved with dev, most of which is much easier than this and a lot more enjoyable, Discord is right here. Other than that, you can follow me on X for more content, including articles you can't find anywhere else. So thank you very much, and I will be back